All right, here we are again, and we're continuing with distance, displacement, and position. So do make sure that you've watched the previous video on scalars, vectors, distance, and displacement first. So in this lesson, we're going to look at then how do these concepts work into calculations. So starting with distance, when we're talking about calculating distance, it's really just a sum of all values, right? You add up any traveling that the object or person did, okay? Here, D stands for distance, and the numbers are just showing you consecutively keep adding up all of the values, okay? Now, displacement is a bit more complicated. With displacement, we know that it's only the difference from where the object started to where they ended. And depending on how the question is worded, you may have to solve this a few different ways. The first method that you could use is possibly just drawing yourself out a number line or somewhat of a diagram to help you picture the scenario, and you may be able to visualize the displacement like we did with the bike and the butterfly. Okay, the second option, and I think it's probably the most common one, is using what is known as vector addition. So this is addition. You are simply adding up values, but what makes it vector addition is that we have to assign direction. We have to assign each direction either a positive or negative value. So this is where our conventions come into play. If the displacement is north or east, we put those in our equation as positives. If it's west or south, we write those as negatives. And then whatever your answer is, if your answer is negative, you know that it was west or south or whichever one you had put in there. Now for this course, we'll only be dealing with two-dimensional direction, which means you'll only be dealing with north and south together and east and west together. So only opposites. Okay, so you are still adding those numbers up, but you need to assign opposite directions, opposite positive, negative values. Okay, the third method, I should say 3, is to use a formula where displacement is equal to final position minus initial position. Now, we can only do this if we actually know the position. So this means we have to know the exact location of the object and not just, how it's moving. And I'll show you kind of how that looks in different scenarios. So again, F means final, I means initial. This triangle you're going to see pop up throughout physics. It's called a delta symbol, and it simply means change in. Okay? All right, so example 1. If you travel 20 kilometers north, then 5 kilometers south, what would be your A, distance? Okay, so distance again is a sum. So the directions actually don't even matter here. We simply go 20 kilometers plus 5 kilometers. Therefore, distance is 25 kilometers. Okay, simple as that. Again, displacement, usually a little trickier. I'm going to show you the first method, which is to draw a number line to scale. Now, because these are north-south directions, I'll draw a kind of north-south number line. So let's say you're here, okay, and you travel 20 kilometers north. So let's say that's 5, 10, 15, 20. Imagine those are all even, please. Sorry. So I'm 20 kilometers north. I then turn around and walk 5 kilometers south. So from here where I was, I go 5 kilometers south. So I'm ending here. So if I started there and I ended here, and with my picture, each of my ticks were 5 kilometers. So I'm now 5, 10, 15 kilometers north. So that's one way to just figure out displacement. Just draw yourself a picture and think about it. Okay, logic it out. All right. Now, with that same problem, you could also have used vector addition, which is probably going to be the more likely way as we move forward. So this is where displacement, I now have to assign positives and negatives. So again, north is typically positive in this scenario, and south is negative. So how does this look then? 20 kilometers becomes positive 20. And I'm adding, it is vector addition, but then 5 kilometers south becomes negative 5 kilometers. All right, positive 20 plus negative 5 becomes positive 15 kilometers. And because I assigned north to that positive, I then convert it back into direction version. So that's 15 kilometers north. Okay. All right, now it's very important that you're aware method 3 here would not work for this problem. We don't necessarily know the exact location of and the exact position of the object at each time. All we know is that they were moving 20 kilometers north and then 5 kilometers south. Okay, those are not positions, that is just movement. So method 3 would not work. Okay, second example. John is standing at a position described by -9. Okay, so this is just saying position and J representing John. So at -9, we have John. Bill is standing at a position described by +3. So notice how it didn't say Bill moved 3 steps to the right. It told us a position which is in reference to the 0. Okay, that's the difference. We know the location of John and Bill. Okay, all right, so what is the displacement? Okay, so first we'll use just our number line in our little picture here. It's important to be aware of direction. We are looking for the displacement from John to Bill. Okay, so Bill is kind of our final location here. So from John to Bill is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 steps in the positive direction. And that's how you'd write your displacement. Now let's see how we would calculate this. So in this case, positions are known. So I can actually use the formula of final position minus initial position. And as I just described, Bill, if we're going to Bill, Bill is the final position. So we write this as +3 minus -9. So that negative is very important. +3 minus -9. Whenever you're subtracting negative, you're really just adding. So we're at +12. Same result we got last time. So that's a scenario where that formula can come in handy. All right, bit more practice here. Jane walks 8 meters east. She then changes direction and walks 3 meters west, and finally turns and walks another 7 meters east. How far did Jane walk? So first we're asked to solve for just simply how far she walked, which is the distance. So the east and the west doesn't matter. Distance is only a scalar. So I'm simply adding up each value. Okay, therefore 8 plus 3 plus 7, distance is 18 meters. So that's how far she walked. What is her total displacement? And think about what methods we could use. Okay, we could draw ourselves a number line here. There's small numbers, we could easily do that. Or we could use vector addition, which I'm going to prefer. You would not be able to use the position formula because again, this question is just showing movement. It doesn't show initial and final locations. All right, so I'm going to choose to do vector addition. Again, east is conventionally positive, west is conventionally negative. So this becomes +8 plus 3 meters west, so -3, plus 7 meters east is positive. So +8 plus a -3 plus a +7, that's going to be +12 meters. Now I'm going to convert that positive now. I'm not going to leave it like this because we are dealing with directions and I had assigned east, the positive. that becomes 12 meters east. Okay, all right, 2 more examples here. Okay, we have a bit of a picture here. Now, if we drove from Portage La Prairie, which is here, I'm going to draw in the picture here, to Kenora, okay, what would be our displacement? Now, I could use my number line here. I could figure out the displacement, the difference between the initial and final. Because I have positions, so these numbers actually indicate location in reference to Winnipeg, I can also use my position formula. Final minus initial. Whoops. Okay, I'm ending in Kenora, so that's my final position, and I started in Portage La Prairie. So this becomes positive 209 kilometers minus negative 105 kilometers. And calculate that out. So positive 209 minus negative 105 is positive 314. Okay, so Kenora is positive 314 kilometers from Portage La Prairie. Okay, next one. Same kind of picture here. What would be your total displacement if you drove from Winnipeg to Brandon, then to Kenora, and back to Winnipeg? Okay, so initial, final. All right, what would be our displacement? So here, we have to kind of think a little bit. From where I started and where I ended were the same place. Therefore, my displacement is 0 kilometers. So don't forget to think about that. Distance is going to be adding these up. So I've got to kind of use my picture here. Brandon is 215 kilometers to the left of Winnipeg. So that was kind of my first interval. Again, positive negatives don't matter now. We're just adding them all up. So 215 plus another 215 plus 209 and plus 209, I believe. 215. And that should be 848 kilometers. All right. Okay, so hopefully that gave you enough variety of examples that you can now do your workbook. So please kind of work through the distance and displacement section of your workbook and then check your answers when appropriate. All right.